The electronics branch in science and technology is a special branch of circuit design that deals with the control of electric current. Now, one can ask, what would one gain when we control the electric current? Now, one can understand that the control of electric current can mean the control of direction of the current, the control of the amount of the current, whether it is amplified, attenuated, or constant, or the control of the start and end time of the current flow. The current control can lead to vast amounts of applications, like it can be used in amplifiers and microphones, or in high-end processors. But to understand this, we need to understand how an electronic device is made and how they function. Electronic devices are made up of special materials called as semiconductors. But why do we use semiconductors in the first place? To need to understand this, we need to see how semiconductors are different from materials like conductors and insulators. The basic difference that comes into one's mind is conductors have 1, 2, or 3 electrons in its outermost shell and can easily conduct even though there is the smallest of excitation. On the other hand, the insulator has 5, 6, or 7 number of electrons in its outermost shell and hence do not conduct even for a significant excitation. But semiconductors have 4 electrons in its outermost shells, which makes them special, and they can conduct when a limited or a finite amount of excitation is provided. This means that a semiconductor material would only conduct in a circuit if it is supplied with a limited but finite amount of excitation. To gain more insight in this, we need to understand the concept of energy bands in solids. Energy bands dictates the energy levels of electrons present inside the atoms of solids. Because of quantum physics principle called as Pauli's exclusion principle, it states that no two electrons will have the same quantum energy state. In simple words, it means that no two electrons will have the same energy. As a result, all electrons in the outermost shell combined will have different energies, which makes it a range of energies, which is called as a band. Hence, the electrons of the outermost shell is called as the valence band, as they represent the energies of valence electrons. But we need to understand one more thing. The energies acting on an electron is not because of its own atom, but also because of the neighboring atoms, as solids are packed closely together. The closer the atoms are to one another, the more likely it is to be influenced by the nucleus of a neighboring atom. In other words, the closer the atoms are, the easier it is to make an electron free from the orbit, as it has more outward attractions from other sources or other neighboring atoms. The energies of free electrons are another band of energies which are called as the conduction band. We call it as a conduction band because they represent the energies of a free electron. And another factor that leads to band energies is the crystalline nature of solids. Metals and semiconductors usually exhibit crystalline nature, which means that the atomic arrangement in 3D space is repeated volumetrically. Hence, depending upon the crystal structure, a single atom can be surrounded by 2, 3, 4 or more atoms, and hence the influence of electron increases. Because of the high density of metals, atoms inside metals are very close to one another and have very less amount of valence electrons, as we stated earlier. Because of densely packed conductor, a lot of atoms influence the electrons of neighboring atoms, and the influence of the nucleus of the valence electrons becomes weak. For this reason, the energy required to make the electron flow is negligible. Hence, one can say that conduction and valence energy for an electron in a metal is almost the same. Hence, when we take a look at the bands, the energies of conduction band and valence band overlap, which suggests that these electrons are loosely bound and can be easily free. This is also the reason why metals have a large number of free electrons. However, when it comes to insulators, their densities are small and have a large number of valence electrons, which divides the incoming influence of neighboring atoms among these large number of valence electrons. Since they are less close to each other, one neighboring atom nucleus cannot easily influence electron of other atom. Hence, they require a lot of energy to make an electron flow. As a result, the energy gap between valence band and conduction band is very, very large, and the conduction for them is near impossible. Finally, when we come to semiconductors, they have 4 electrons in its outermost shell, and also the interatomic distance is less than insulators. As a result, there is a finite amount of influence of neighboring atoms to electrons of a specific atom. Hence, they do not require a lot of energy to make the electron free. For this reason, the band gap between valence and conduction band is smaller as compared to insulators, and that much amount of energy can easily be provided by an external source. Therefore, one can say that if a semiconductor device is used in a circuit, It will only conduct if the supply is enough to overcome the energy band gap. Since that can be easily overcome, we can use the existing excitation sources like batteries to do this work. This gives a somewhat control over the conduction of charges and hence the current inside circuits. As a result, we can dictate when devices would conduct. As a result, it is suitable for circuits where control of current is required, and hence they are used in electronic devices.